Okay, good morning, everyone. We'll go ahead and get started while people are still joining, but thank you so much for joining us today and welcome to the Hive Think Tank series webinar. My name is Olivia and I'm the operations manager at the Hive in Silicon Valley, and we're super excited to have you join us and hear from our expert panel speakers with Mike and Sam from Databricks and Alistair Croll. So with that being said, I'm going to quickly go over some of today's best practices for the webinar and then explain what the Hive Think Tank does, and then I'll pass it over to Ravi, who's our founder and managing director. So we do love questions, so we would love for the audience to utilize the Q&A button and not the general chat box at the bottom of your screen to ask them any questions, which they'll do so at the end or kind of throughout the panel discussion. And then the session is also being recorded, so it'll be available on YouTube later on this week. So the Hive Think Tank is an ecosystem of thought leaders, corporations, and entrepreneurs. We're an event and content platform with a focus on AI, enterprise, security, sustainability, health tech, and so much more. So we do host events almost every other week on cutting edge topics in technology and business. So we would love for the audience to join our meetup group and newsletter just to stay up to date on all of our upcoming events. And I'll link that later on in the group, in the chat box below. We do have also another webinar coming up in June, so I'll have Ravi talk more about that. And then lastly, I want to thank our sponsors, Avanta Ventures and Gamuda, for their support. And if anyone is involved in getting involved with the Hive Think Tank, feel free to reach out to me directly and I'll link my email down below. So with that, I'll go ahead and pass it over to Ravi.
Great. Thank you, Olivia. Just a brief introduction of the Hive. The Hive is an early stage fund, typically investing in seed, pre-seed, and in a number of cases collaborating with entrepreneurs to start companies. We've been around since 2012. We're in our fourth fund, and with a general focus on data and AI. And we also have a global presence in addition to our US-Canada investment. We also do investments with separate entities in Brazil, Southeast Asia based in Malaysia, India, and very soon we are launching a sustainability AI fund in Europe based in Paris. So if you're an entrepreneur in the general area of data and AI and its applications and use cases, we'd love to hear from you. Next slide, please. We are launching a whole series of events on generative and AI and LLMs. And so one of the events that you'll see us post soon is the application of generative approaches on non-text data. Think about life sciences data, machine log data, financial data. So, it turns out that generative approaches work pretty well in this space also. Next slide, please. And so it's my great pleasure to introduce Alistair Croll. We have known Alistair for a long time. Alistair is an author. He's been in operating roles as an entrepreneur. He's an organizer of conferences. Many of you are familiar with him through the O'Reilly Strata Conference. We love Alistair because he is really on the cutting edge of things, and we couldn't think of a better person to host today's event. Alistair?
Thanks a lot, Ravi. And I have to say, I'm incredibly excited for the opportunity to talk with Mike and Sam, because as you all know, what's been going on in our feeds is a flurry of, hey, these are 5 great prompts that will save you 100 hours a day. And, the hype is pretty remarkable. So I'm thrilled that we get to dig beyond the hype and talk to some of the people who are actually building these tools. Mike and Sam, why don't you both give us a quick background on who you are?
Sure. I'm Sam. I'm VP of Engineering at Databricks. And before that, I founded an AI startup called Skipflag, which was acquired by Workday. And then before that, I was an early employee at LinkedIn, where I ended up building a lot of the kind of data products and features and infrastructure on that site.
So it occurs to me that I can just copy and paste Sam's bio. He and I have been working together for the past 10 plus years. I was at SkipFlag and Workday and Databricks. Now working with Sam, I am the co-creator of Dolly. And yeah, that's the long and short of it. Whirlwind tour of the past 10 years of my life.
And it's amazing how many interesting things came out of LinkedIn's early days. Says something about the kind of data that's useful in there. So a couple of ground rules for what we're going to do today. This is a very open conversation. It's speculative, so please don't trade on any of the information that we share here. The goal is really to talk very broadly about the impact of large language models, and then by the end of the conversation to get to some of the more concrete applications and challenges and discussions about where it might go next within just an hour. So let's pack it full. Sam, why don't you start out by just explaining at a very high level what LLMs are for those that aren't completely familiar with them?
Yeah, an LLM is a type of AI model that can process and generate human language. It uses like neural networks to learn patterns and relationships in large amounts of text data. And these models have been trained on like text data such as books, websites, social media, which enables them to generate coherent and contextually relevant text. So, and they have practical applications like language translation, chatbots, which I'm sure we'll get into. Some examples of LLMs are GPT-3 or ChatGPT from OpenAI, Google's BERT are two good examples of LLMs that are out there.
So, Mike, one of the dumb questions that may not be dumb is, how come an LLM doesn't give you the same answer for the same prompt each time?
I mean, so one of the ways kind of to bridge from the first question to think about these technologies is that they sort of are lossily interpolate between a representation of world knowledge, and that they kind of have conjoined in them both language generation capabilities, which you might refer to as like coherence, and then knowledge, which is just sort of like fact-based reasoning. And so like, you know, that your question kind of gestures to like, well, they're wrong sometimes. That's interesting. And they're different, you know, I'll give you a different answer for the same question. And so that's like, you know, I guess, you know, don't have a great sense for the technical background of the audience. And so like, help me, Alistair and Robbie, kind of dial the response here. But you know, it's generating these by picking the next word. It develops an internal model given a prefix of what the likeliest next token in a sentence is based on every prefix it's seen on the entire internet, and then private corpuses of books and scientific papers and patents and things like this. And so you're basically flipping coins, you know, 50,000 at a time. But you know, sometimes it's the word aardvark and sometimes it's the word chinchilla. And you can think of a branching tree of possible sentences that follow that greedy generative process.
So inconsistency of response is kind of a feature and not a bug, because that's what allows the creativity, right? If everybody who typed the same prompt got exactly the same answer every time, it would kind of just be a search engine.
Yeah, I mean, it's kind of a feature and a bug, I guess. Like, and you think about, so for creative writing tasks, right? That ability to, you know, sort of make things up as you go is actually really, really valuable. In the enterprise, if I'm building jet turbines, I'm not that interested to pay for a system that lies to me convincingly. That's not helpful. So I would say that it's a big open problem for the space, and I think very application dependent.
Okay, Sam, one last question before we get into the implications of some of this stuff. There was a paper about attention, and people keep talking about attention in large language models. Can you explain what attention means to in someone designing a large language model, and why the idea of attention is so important for producing good results?
Well, I'll let Mike take that one. I think it'll be more.
Sure. I just gave this talk, which is why Sam's kicking it over to me. So, you know, it's at Databricks, we are all in on this. And so like helping everybody at the business understand issues like this, I think a little technical knowledge goes a long way. So I'd be happy to share kind of how I understand it, at least. If you think about looking at, have you ever seen like heat maps of like eye tracking, where you would like look at the where on a screen a person is looking, or a piece of paper where they focus their attention. This is sort of like what's happening in these language models. If you think about the inputs to a language model as being the words in a sentence, and each of those words has a corresponding vector associated to it that captures the semantic essence of that token. The challenge that transformers and the self-attention module in the transformer really address is that words, you shall know a word by the company it keeps. So AI in one context means artificial intelligence, and in another context might mean action item. And so really you need to look at all of the other words in a context window to create a representation of a single token. And so attention is really a weighted sum over the embedding vectors for all of the tokens in a sentence. And then when you talk about, stacked multi-headed self-attention, you just layer that process deeper and deeper. And this is kind of similar to in the visual cortex, how at the very earliest layers, and this convolutional networks have made this analogy too, but I think it happens in transformers, you have just like edge detectors. And then those interactions between the edge detectors give you like pattern and texture modules in the visual cortex. And I think that as you stack those interactions between words, you get higher order semantic concepts. And that's sort of how it becomes like a lossy compression of world knowledge and language simultaneously.
I think you should know a word by the company.
Did I get it right?
That should be a t-shirt. Yeah, that's we'll start the LLM merch now.
I didn't
okay, so
like
no, that's a great analysis, and we have some questions in the Q&A. I should point out we're going to try and take time for questions in Q&A. So we got 2 already. We'll try to get to them at the end. If we can't, we'll answer them on LinkedIn or somewhere else, or make another webinar about this, because this stuff is amazing, and I'm incredibly happy we get a chance to talk about it like this. Can you talk a little bit, Sam? I'll hand this one to you now. What do you think are the short term, like 6 months, maybe 3 months even, given how fast things are changing, and the long-term implications of this technology being sort of abundantly democratized to the average person?
Yeah, totally. So I think the first thing is to understand, how should you think about this technology, right? And the way that I think about it is generative AI, which LLMs are a subset of, will eat areas where it takes a large effort to create content, but it's very easy to verify that content. So what I mean by that is, like, if you are a lawyer and you have to read a bunch of case law to understand precedents for a case you're doing, and that may take you days, weeks, to understand that. An LLM can go and look at all of that and generate that summary for you, and eventually we have the ability to put citations in there. So you can easily look at that and be like, oh, it's verified, correct. Another example you can look at is we're getting really good at being able to generate images and like videos from like human language and text. And so eventually everyone will be able to become a Hollywood movie director by just being able to talk to the computer and generate like the movie that they want. Again, that's very easy to verify. Maybe I'll give you a third example, and this is maybe the most clearest example, is like code. I can create a napkin sketch and have the LLM generate the code. It's very easy to verify if the app is correct or not, because I get it to compile and I try it, right? So again, I think if you put this lens, generative AI really thrives where the content is tough to make, but easy to vet. And if you look at that, there's like vast areas that are going to be transformed, right? Anything where there is this drudgery or difficultness and generating the content and sifting through language. But then it's very, very easy to see if the results are correct. And we could spend the rest of the entire time talking about all the various applications. But I think that's the lens.
Yeah, but that's a good meta lesson, which is like the asymmetry between the creation and the verification.
Right.
It seems to me like increasingly, we had this idea that AIs are going to take away all our drudgerous jobs, like filing taxes. But it seems to me like in many cases they get to do the creative work, like storytelling and image painting and so on. But then humans have to assume the liability. Like we become a liability sink because there's no way to make the model liable. It's a black box. So it seems to me like one of the big consequences here is the doctor can use the AI, but the doctor gets sued if the diagnosis was wrong, because we don't have a legal system for enforcing correctness of the output. So how do you think this is going to, Mike, maybe I'll hand this to you. How do you think this is going to change the legal system when we have things that are, as Sam said, easy to verify, but like you're in trouble if you didn't verify it right?
Well, I will tell you that I am not a lawyer. It's an interesting question. I think there got to be parallels. I mean, you think about accountability in system design. Like this is this really specific to LLMs? Like in the sense that like if I build a jet turbine or a drug that somebody takes and they, have a catastrophic outcome, like I am still accountable for the result of that. Like I think we sort of, I mean, certainly like self-driving cars have kind of this interesting characteristic. Well, it's like, is it the driver or is it the system that is accountable? I don't know what, I'm a software engineer. Like I'm a pretty creative software engineer, but like, I think that is probably out of my depth to answer definitively.
That's fair. And I think there's a lot of lawyers asking for that question. I'm long on law firms. This is really the first
standards for depending on the riskiness of the application, right? So like applications where there's a consequence is going to be wrong or improper decision could be really severe, require very, very high standards and considerable oversight and regulation, right? So like if you have an LLM for determining credit or reading applications for public housing, that requires a lot of thought, right? You have to have privacy to protect an individual's data when you're training the model, fairness to remove biases, explainability, so you have like clear reasons for the decision making. You need robustness so you can like not deal with adversarial attacks. And then I think it's really crucial in like things like that where they have very, very risky is that there is an appeals process with human oversight of the model, right? To like ensure that kind of happens. And then, but I think like, and then this is like early innings of this. And so we need to think through what the actual legal and ethical implications of this are. But like maybe I'm giving you like very, very broad strokes of how I would think about it.
Yeah. And if Alistair, can I riff on that just a little? Like, I think from a technical standpoint, there are probably like trade-offs. So one thing that's really notable is that these models, as they're generating, can produce incorrect statements, but then you can show that entire statement to the model again and say, is this true in the context of like this passage from a corpus? And it'll know that it was wrong. And part of that deals with the attention matrix and the fact that it is only attending to the tokens that have come before it makes that greedy decision about what comes next. And then once you have the entire passage, it has more information on which to determine whether it's right or wrong. For some of those mission critical applications, you might have to deal with longer inference times where you run it through multiple subsequent models to determine, is this fair? Is this correct? All of the things that are from a regulatory and control standpoint appropriate. And that we may just have like knobs that we can tune in terms of like how much is speed versus like absolutely like controllable correctness important.
Truth or dare kind of knob. Okay, we came up with a bunch of questions. We got some in Q&A here. First one I want to throw at you. This is really the first piece of software that has zero learning curve. Like it literally tells you how to use it. In fact, it wants you to use it and starts coaching you on it. What do you think that means for the breadth of adoption, the rate of adoption compared to other pieces of software?
I think it's going to be a huge change in HCI, which is human computer interfaces, where there was always like this, adoption curve that you had to deal with, of basically learning how to use this, the UI or the hardware or the software and understand that kind of how it works. Photoshop is maybe the most complicated example where you need to spend, probably like weeks learning how to do anything reasonable in Photoshop. But now you can just talk to it and like it will do what Photoshop will do for you in seconds. And so that it's really changed the game of like what that looks like. Now, does it look like Clippy from, if you remember back from the office days where you just have this little thing that you just talk to it, or does it allow us to create more and better UIs? I think the latter is true. I think like the IRC window of just talking things is probably like version 0. It's going to get a lot better. I don't know exactly what it will look like, but I think it allows us to like have whole new interfaces to computers that we haven't had before.
Okay, Mike, I'm going to ask you the big question. Are we at a singularity? And I don't necessarily mean the Kurzweilian end of humanity singularity, but like the Foucault singularity of the future is unknown or unknowable, and we can't really predict what will happen. And I know you had a great metaphor about stem cells, so maybe you can work that in. Consider that your prompt.
Sure, prompt. Yeah, it's funny. Yeah, we are all prompt engineers. So I will say that, I think of this kind of like hurricane forecasting. So like the bands on the forecast have expanded significantly. And so in that sense, like, yeah, like the Foucaultian, is that the way to say it, Foucault, singularity, like I would say, yeah, like there is a non-trivial likelihood that the models we use to reason about the world today do not apply to the world 5-10 years from now, and maybe even shorter than that. But I also think, like, when it comes to questions of like to AI takeoff, or like the sort of more classical example of the singularity, like those are like, it's fun to talk about, but it's actually somewhat less interesting to me, in the sense that, like, well, these technologies absolutely do something specific that is valuable today, and they also have really concrete flaws. And like, I think if you sort of throw your hands up and say, like, all of my reasoning tools will not be useful in the future, then you don't have any means by which to judge how I should act now. And we're, especially at Databricks, a pretty like applied and results focused group. And so I would say that, like, I believe that in 18 months, in 36 months, databases will still exist and will still be important. And like, maybe there's a scenario in which, like, all is subsumed by a global scale super intelligence. But I don't, like, I will act in that world if we inhabit it, and I will not plan for it. So, I actually,
well, the good news is you both get to keep your jobs because you're the ones that help the thing.
We'll see, right? We'll see. Yeah.
So moving through these fairly quickly because we have a limited amount of time.
Sure.
You just mentioned, Mike, that you're very focused on like tactical applications, putting this stuff into production, finding real uses for it. And we've seen a couple of questions already, great questions in the Q&A. Lokesh mentioned, LLMs and generative AI are very good to show awesome demos. But when we try to build production-ready apps, we go down the rabbit hole. There's this ambiguity that you've mentioned, the sort of uncertainty, which can be a feature and a bug. There's unexplored paths to provide accurate estimates, to fix issues. It's very hard to know how to troubleshoot the black boxes. How do you think LLMs will be incorporated into software in the short and long term?
Yeah, I mean, so I'll actually bridge back to a previous question you asked, which is like, they are a tool with no learning curve. I actually somewhat disagree. And I expect that you also feel this way, that like prompt engineering is not obvious, and that it actually is very iterative, and you kind of like have to figure out this bag of tricks. The other side of that is that, like, they're a very crummy API, right? Like, even with some of the most sophisticated tools, you can say, I want you to give me a list numbered 1, 2, 3. And 19 times out of 20, it will give you a list numbered 1, 2, 3. And you can parse that response. But the 20th time, it's just something else. And it's like your call fails. And so I think, like, this is kind of related to the, like, well, how do you deal with these non-deterministic algorithms? And I think, like, there are businesses that question begs an answer of, where it's like, okay, how can I manage that stochastic character of these models? How can I constrain them so that they do the thing that I want? I think for this to not be another hype cycle, we will have to land that, like, okay, it has like concrete, reliable value in several specific scenarios that are not just the open-ended text generation domain.
Yeah, it seems like for subjective things like art and content writing, pretty obvious that you don't have to be perfectly right. But I really like that idea that in the old days, we wrote software with an idea of what it could do, and then we tested to see if it was doing that. And here we have written a thing and we test it to find out what it can do, which is kind of cart before horse. Sam, what are your thoughts on how this stuff is going to get incorporated into software in the long and short term?
Yeah, I think in the short term, there's a lot of applications in the enterprise. I mean, customer service, chatbots, I think, are an obvious place where you will get personalized support and assistance. Email automation, where you can generate, natural and human-like email responses and do more effective customer communication. Document generation, where you can generate legal contracts, financial reports, and other things. I think data analysis and BI, where you can analyze a large amount of text data, say all the customer feedback that you're getting as a company, and understand the insights and say, what are people really complaining about? What are the real trends? I think you can understand business data and provide recommendations on decision-making. And then even something like cybersecurity, right? Like using LLMs to understand the complex patterns of how people are interacting with your site or your product and identifying threats before they can be exploited are all things that I think in the near term are going to become much better with these LLMs. And I think it gets back to what I said earlier. These are all applications where it's very difficult to generate, but easy to verify, right? And so like, I think those are the things that you're just going to pick away pretty quickly. And then, the more complicated things, I think we need to figure out how to constrain the LLM so they don't like hallucinate, which is a nice way of saying is that they're, wrong. And that I think requires a lot more research and a lot more work, but I think that will change in the next, 12, 18 months for sure.
Yeah, it's an interesting euphemism that we've chosen to call it hallucinating. I don't know if that means that everyone in the valley is microdosing or if we just don't want to say the word lied, right? Yeah.
Well, the truth is that humans are always hallucinating too, right? I mean, I have certain sensors, but I don't see the electromagnetic field that a shark does. So like, I am coherent and rational with the sensors that I have, but I don't actually know everything else that's out there, right? So like everyone is almost hallucinating all the time.
Yeah, in many ways, it's actually fostering a discussion of sort of mental health and perceiving the world. So let's do one more philosophical question, then we'll get into Dolly itself. Meta has an AI called Cicero, and it was put to work in a game called Diplomacy, which is kind of like if you took Risk and Werewolf and locked them in a room for a while. It's really good at negotiating and finding shared outcomes that everybody's okay with, like better than all the human players. If an AI can outperform humans on tasks like negotiations, first of all, doesn't that make sense that like every single country at the UN should have a chatbot telling them what to say? And second of all, why are the humans there? Can we just solve the world's most intractable problems by pitting AIs against one another and like making, every international dispute in the UN Security Council has to be first arbitered by a chatbot? Like, what are your thoughts on how we can use this to solve some of the world's really intractable problems?
So I'll kind of jump in here. I do think that the preference elicitation is like the real. So I believe that like if you look at like AlphaGo, it plays in a way that is near like poker is another example of a game that now is known to have game theoretically optimal solutions that are just unexploitable and very difficult for humans to implement, but for an AI system it's just decision sort of matrices about what to do in a given circumstance. We struggle to imagine that would generalize to something as like nuanced as like negotiation or language, but I believe it probably does. The issue is that like articulating exactly what I want in its exhaustiveness is probably very hard to do. And that's kind of like another thing about like, are these things really zero learning curve? I find that writing down in natural language my needs for a program is actually more difficult and sometimes intellectually taxing than just writing the code. And so like, I do wonder if we will get to a point where you trust a system enough to represent your goals faithfully at that very like sort of the stakes could not be higher scale. And then whether like a group of people representing a nation state could decide on the instructions that they gave to their game theoretically optimal negotiator. So it's like the human element that's maybe a question for me.
That's fair. Okay, let's get into Dolly. Why create Dolly when LLMs already exist?
Shall I field that,
Sam, I'm going to pick you.
Sam,
right. You get to do that. Why'd you make Dolly if there's already LLMs out there?
So the reason we created Dolly was really that there are other models out there, but in some sense they're in a jail, right? You require either API access or you have to be beholden to your data being used to be trained inside that model that's there. If you look at more of the open source models, a bunch of them used inputs that had unclear legal provenance. So it wasn't like the models themselves are not to be able to use in commercial applications. So we wanted to create a really truly open model that anyone could use for commercial applications and the resulting training data sets for those applications. So anyone can take what we've done and use it to build, the next versions of things on top of it and use that for their own internal enterprise applications. So it's really the whole idea is to like democratize and make these LLMs much more open for everyone out there. And that was the genesis of Dolly. And that's kind of how Dolly 1.0 and 2.0 kind of came about, was this ethos of how do we make these LLMs more open and more democratic so anyone can use them for whether it's commercial or non-commercial applications and build on top of that in a very open source kind of manner.
So one of the questions that several people have asked me, and I don't have a definitive answer, but I kind of have one, is if I'm using a commercial closed LLM, like for example, ChatGPT, there's this case where someone from Samsung apparently pasted a bunch of the company's code into the chatbot, even though it was proprietary and open source, and now it's leaked. Has it leaked? Does the model now incorporate Samsung? Is every response from a chatbot and prompt from a user part of a later model? Like, what are the value, and how does that factor into the idea that you need to have your own LLM that you can lock down in order to be candid with it? How much leakage is there when you're using a closed box LLM you don't control?
I think like the Samsung example is an interesting one from a control standpoint. So certainly like that's a really easy like use case for something that you own and operate. And like, one of the things that, we've been really clear about is that Dolly is not a state-of-the-art model. It is not a drop-in replacement for ChatGPT, but it gestures in that direction. I think in the next couple months, you're going to see, or like probably weeks actually, somebody released a llama clone trained on, a non-trivial fraction of a trillion tokens, and that you're going to have a step function in quality. And then additionally, we really believe that the data, the transformer architecture like has not really materially changed since the original paper. You've had tweaks to it, but really what is materially advancing the state of the art is the data. And so that was part of our thinking in releasing a data set of these questions and question and answer pairs that imbue this instruction following data, or this instruction following capability into this legacy model. I think that within the enterprise, you have these incredible data assets that you just can't. It's your IP, it's your code, it's your best thinking, your thorniest problems, the real skeletons in the closet of a business. Hey, this phone is catching fire. Like, you really need to like act meticulously. And so like to the extent that businesses are able to build tools where they have excellent operational control and observability on how those downstream assets are used, we think there's going to be a lot of demand for that, and that the technology, like no doubt, like Anthropic, Cohere, OpenAI, they have some really, really powerful models. I think a major part of their advantage is the data flywheel that they have for using models to generate new training data and then subjecting that to human criticism and kind of essentially bootstrapping the data sets that they train these models on. I believe that enterprises are going to be able to do that as well. And that, when we've talked to customers, clear is always better. Like, the reason people love Dolly V2 is because there's just no ambiguity. You can use this to build a business. And likewise, when you own and operate the thing, you understand exactly where your data is going.
I mean, let me dig into what you just called the LLM flywheel, which I love.
Yeah, sure.
I was joking that, I listen to a lot of bleep and blorp ambient electronic music whose band names I never remember.
Sure.
Spotify is the perfect training algorithm for Spotify to start generating music for me and paying no license fees, because it can just shove things into my playlist and then find out if I like them and save them, right? There is something to be said for setting up a platform, like the fact that ChatGPT and OpenAI got first mover advantage on the chatbot means that they had a million eyes on the data very quickly. Louis-Eric Simard just asked, and I hadn't heard this term before, how do you prevent a Boer loop of LLMs getting trained inadvertently on AI-generated content? How do you stop LLMs from becoming narcissistic?
Sam, do you want to take a crack at that?
It's a difficult problem. What you don't want to do is create this resonance where you're like, using AI to feed into AI. There's no such thing as a perpetual motion machine. It doesn't work. And so you have to be very cognizant of understanding where you're getting your data from. And this is why I think the provenance of training data is going to become much more of a bigger issue in the future. You already see that, training on the web where there's a lot of like low quality content that's generated, and you have to sift that out if you're training and building these models. It's an open problem in research, I think, but I think the provenance of training data is going to become much more crucial in the years ahead, and the people that have actually good, clean data sets will be the ones that will benefit quite a bit from that.
Let me, Alistair, kind of also, it's probably less data than you think. And so that's kind of the benefit of a web scale corpus is probably mostly to imbue those language capabilities into the model. There are probably techniques that look at, there's steganographic techniques to encode the fact that this, based on the probabilities of the tokens that are selected in a sequence, to encode the fact that this was generated by an AI, sort of like a digital signature or watermark. So certainly it's possible that on corpus construction, you could look for those statistical tells and omit those from the corpuses. I think you look at the Llama paper, they took, I think, a multi-petabyte common crawl scrape and boiled it down to about 3 terabytes. So like, and really data quality is paramount here. And with like the Dolly result and the Alpaca result likewise show that you can have this trillion token pre-train and then 50,000 additional records materially change the behavior of the system. And so, certainly that like poisoning the well, I'm not familiar with that Bohr loop, but that analogy, but I think I understand is an issue, but like data quality and cleansing is going to be more and more important. And you may not get the benefit of a web scale scrape that is, polluted by those AI sort of traces relative to a highly curated, super focused, small corpus of demonstrations of exactly the behavior you want.
And I like that distinction that there's 2 things going on here. One is the ability to understand the question. The other is the ability to answer it. And corpuses are different for the 2.
Yeah.
Because if the AI generated content was sensible, it may be a good source of training on language, but it's a terrible source of training on response if it's feeding on itself. You mentioned something about step functions and the number of tokens. We've seen significant increases in emergent capabilities. I asked ChatGPT 3.5 in preparing for this, because I always like bad jokes. I asked it to explain the following joke to me. If you're cold, you should go stand in the corner because it's 90 degrees. That's the joke. I'm not telling it right,
is a bad
but
joke.
it's a terrible joke. Right.
It's a good bad joke.
Right.
Yeah.
Basically, if you're cold, go warm up by standing in the corner. Why? Because it's 90 degrees. I asked ChatGPT 3.5, and it gave me this whole thing about the word warm up and how you'll burn calories walking to the corner. Yeah. GPT-4 was like, it's a pun on the words 90 degrees. And it even told me it only works if the person lives in a country that uses Fahrenheit. I'm like, that's a pretty good answer. That's a step function kind of response. And we've seen several of these emergent properties where it can draw a unicorn or whatever as a result of getting bigger. What is it that what is your best guess on what it takes to achieve these step functions, and whether we will continue to see them, or are we in a sort of sinusoidal curve where fewer emergent capabilities appear as we add incrementally larger corpuses?
So let me push back a little bit on that. I think the large providers, not just OpenAI, but everybody who's in this game, benefit from a degree of like magical thinking about this. I bet they paid for a corpus of joke explanations. I think it really is that simple. And that, there's in the news are sort of claims that, they're paying teams of programmers to answer LeetCode code style programming problems. We saw when we moved from the Alpaca data set to the Dolly data set, which was generated by Databricks employees in a semi-structured fashion, as opposed to the like rigorous self-instruct protocol that Alpaca followed. like certain capabilities, like really templatized letter writing, are not present in Dolly v2 that were imbued to the model by v1, by the alpaca data set. I believe that we are moving into a future where you can buy a targeted corpus of capabilities and like imbue the model with a behavior, and that a lot of these large providers are just moving deeper into that tree of classes, like recipe generation or summarization, but in the tone
I know
of,
Kung Fu from the Matrix. I love that analogy that you're like buying modules
yeah,
to upgrade.
or like a power up in a video game, right? Like, so I bet they just have paid for a corpus of joke explanations because it's a thing people know to ask about. And that you have, you know, so the Flan data set, which was Google's, you know, 1,800 different tasks that they used to train their sort of like gold palm model to do instruction following. That suggests that there's this like regularizing characteristic that if you have to be able to do many different things, you choose not to do any of them well, and you develop like an internal representation of like theory of mind and world knowledge to be able to interpolate between them. But I think that like my sense is that a lot of the toy examples of like sparks of AGI actually may just be artifacts of the training regimen.
And there's definitely an arms race, because if you're trying to find those properties and then someone sees the video, they go put it in the model. So
yeah, it's
a weird black box arm race
right?
going on. Yeah.
Yeah.
So many of the laws that we've come up with over the years seem to be applying to this in real time, which is like all the stuff that humans did at scale on the internet. Here they are, right?
Yeah, maybe it's not so much a singularity, and our old tools actually do apply.
Yeah, it's just the old ways are still valid.
Yeah.
Okay. So you mentioned a little bit about how Databricks trained this, that you had a whole bunch of employees put in the I would say elbow grease, but that's probably not the case. At least the repetitive stress injuries of typing these things. Yeah. Can you describe that process a little bit?
Sam, do you want to field that, or shall I?
Go ahead, Mike.
Yeah, I mean, so one of the things at Databricks that we're super fortunate to have is an executive team who gets it. Like, we have people in leadership positions who believe that this is going to be a transformative technology and that we should seize the moment, and that we're uniquely positioned to do so. So effectively, you might wonder, like, well, how do you get, 5,000, 7,000 people to generate 15,000 responses? Well, it helps if the CEO just sends an email twice a day, naming the people who've generated the most responses and saying, this is important, please help. So you have on one side this top down, like, this is a moment, this is important, be helpful. And people are incentivized towards pro-social behavior. They, this represents the company, do the right thing, be thoughtful. You look at some of these responses, people were writing short essays. The other side of that is that people, the Databricks employees, my colleagues, recognize that this is a special time, and that, like, this is a chance to, I think there are a lot of businesses at our scale who might not be so daring. There are a lot of ways that you could see this getting caught up in bureaucratic wheels and not ever happening.
Your OKR is how many prompts you've answered.
Yeah. I mean, or just like, hey, we're not sure that we want to put all this text on the internet. But, we had that executive support, and then people who recognize that this is like a special time in human history and want to be part of something. And you just, it can't happen without both. And those were both in the same place at the same time. And now we have this incredible artifact that I hope will shape research for many years to come, and commercial.
So what is the difference between Dolly and Dolly 2.0?
Sam, do you want to speak to that?
Yeah, Dolly 2.0 is based. So Dolly was the first thing where do this thing called instruction following, where we can take a open source model from a couple of years ago, train it on a small number of records of this instruction following behavior, and get it, or fine tune it to a point where it can mimic what ChatGPT does. Now, the challenge with that one is that the input, the training data set that we use to fine tune the model has a license which it can't be used for commercial applications. And so with Dolly 2.0, we got 5,000 plus Bricksters, employees of Databricks, to generate these Q&A pairs and use that to train or to fine tune the model, which then allows commercial applications. We've freely licensed the underlying model, the code, and the training data. So Dolly 2.0 is like completely open and it allows commercial applications and non-commercial applications of it, so people can go wild. And we're really excited to see what the people build on top of it, both data, the code, and the model.
Okay. We have seen a couple of, so one of the early kind of stump the chatbot things was how many words are in the answer you're going to give me. And a human can go 1 and we're done, right? But because it's always moving forward and it's not sort of reflective, the chatbot can't really know what it's going to say until it's said it. So if you ask it a second time, it's no problem. But one of the ways that we've kind of thought about this is these ideas of like imbuing some kind of goal seeking through auto GPT or other models where a single chatbot is spawning other chatbots. But, and if you can follow my hands here, there's a difference between giving a thing a task to make a bunch of tasks, which it then spawns into subtasks, and moving through time in terms of like, I have a task, now I'm going to take that and move to the next one. I'm going to reflect on what the second one may look like before it happens. What do you think are the implications and frankly, the limitations of tools like Auto GPT to imbue goal-seeking approaches or stringing together a series of prompts to produce a result? Is that real? Is it, how far can it go? Where's it going to bump up against, you know, true planning?
So I would say that, like, you know, one of the reasons that these systems are like demonstrably not conscious is the lack of state. Like, it basically, the weights of the parameter matrix just are fixed and you're just pulsing stimuli through them. I think real planning probably, like, even the tool, like Toolformer and like ChatGPT plugins, like these things all gesture to the idea of like external state. I feels pretty like, I believe that the transformer architecture and like effectively like backpropagation is an extremely elegant and general solution. And that's part of why it's been so powerful, is that I mean, it's just mathematically beautiful, the approach. Bolting a vector database onto that architecture seems like a pretty hacky affordance. And likewise, I think encoding in the prompt, like a record of what actions have happened to dates also seems hackish. And so here's
using the context window as memory storage.
Yeah, and it, you know, there's like cute tricks where it's like, oh, have it encoded as emojis or in like your secret GPT language, or, you know, it's like you can compress, but you're still just like struggling. I think what's more interesting to me is, you know, we have these models which are defined by these tensors, and then we're forcing them to communicate with one another in English. So it's like a corroded, because we know that that matrix effectively at the top of the transformer stack that is used to generate that next token could generate any of many sentences. So really, why not let the models communicate using those matrices rather than having to encode it poorly in English, our sort of like weak language for communicating ideas? Likewise, I think like the ability to have at training time the knowledge store layer sort of represented in the training regime is going to be important to developing capabilities like planning, and the ability to like actually have a stateful representation of the world state that is explicitly encoded into the objective function, I think seems important. Reinforcement learning is not my area of expertise. There are a ton of things I don't know about. Maybe this is a solved problem. I don't know that like any of the current suite of proposals that I've seen seem like obvious, elegant, durable solutions.
I remember in 2021, I said this is the year of the objective function. I think I may have been a couple of years early, but I had read a bunch of paperclip blogs, but it does seem like it's pretty relevant. Okay, so I have a question. A friend of mine, Reuven Cohen, asked me a question the other day about what are the SDKs like, and what are the, you know, how do we create on-ramps for both programs and humans to use this kind of technology? So Any thoughts on like SDKs or allowing programmatic interaction with these things? Crickets? Sam, you want to take that?
Yeah, I
What
can
are your
give you,
thoughts on
I'll do a
adding
plug.
APIs and SDKs to that?
Yeah, I think like, so right now, if you want to do, run your own LLM, there's a small like coterie of places you can actually do that. And Databricks is one of them. And so we put a lot of investment into making sure and building an ML platform that makes it really easy to both build, deploy, test, and monitor your ML application, including LLMs. And so there is, if you look underneath the iceberg, there's a lot of stuff around dealing with GPUs and all this complicated data movement that like these platforms abstract from you. And I think that we'll see that one and a few platforms emerge that will basically make it very easy to do these LLMs. And we're investing a lot of Databricks to make it us.
Yeah. And thanks for keeping this non-salesy. Obviously, you have a tech stack as well, but it does seem to me like so many of these things work well when there's an API and there's tools that the model can go and ask. I think some of the integrations with like Wolfram Alpha and so on are really promising because then you have a reasoning model attached to it. We have 10 minutes, or a little less than 10 minutes. We have a bunch of great Q&A, and we've touched on a few of them. We mentioned a little bit about what responsible AI looks like. I'm going to go through these questions and cherry pick them from the questions that we have, but we can maybe answer some of these other ones. Eswar wanted to know, is a fine-tuned model a new model?
There is robust epistemic precedent here, the ship of Theseus. If you replace every plank in a boat piece by piece, is it the same boat? I think it's just like, what is the edge of a cloud? It's like kind of a poorly defined question. Like if we permute the weights by some epsilon, we randomly permute every weight by a vanishingly small float. Is that the same model? I don't know that any answer to that question is going to satisfy all parties.
Yeah, I learned the other day that there is a
disagree?
unicellular dog. There's a unicellular dog because apparently there's a cancer from dogs that's contagious. So technically it's a single cell dog that reproduces itself. So yeah, the epistemics we border on the edge of philosophy there.
Yeah, I mean, Sam or Alistair,
I actually think it doesn't matter. Like, it doesn't matter.
No, it's an interesting question. That was not to be oh, I see it deleted from the Q&A. It's not to be a dig. It's just like, yeah, it's just, I mean, and there's probably legal implications for this. I think that it will be important to get like clear on. I just think that it's extremely fuzzy philosophically.
And we're seeing already like Adobe is launching its image hallucination tools. And one of the reasons they're saying to artists, use us, is like, use us and you won't be listed in a class action lawsuit from the internet. So there's definitely questions around there. I'm clicking answer. I didn't delete the question. I'm just answering them as we go. Okay, we have time for like 2 or 3 more. And those of you that are watching in the Q&A, you can actually upvote the questions you want. So click that little thumbs up button and we'll jump to that one next. Manika's question has 2 upvotes. So following Facebook rules, I'm going to ask that one question next. Going beyond text and creative applications, I'd like you guys to describe LLMs in more constrained settings, for example, jet engine design, which you referred to earlier. To Sam's point, it's easy to verify something could fly or not. Do you see something like a combinatorial model filtering out hallucinations, or is that too brute force? And speculate on how much improvement they will be over current approaches.
And so that a lot of what actually happens under the hood is that the model is generating a few different options and it's picking the best one out of some objective function. So that like brute force of like thing is actually the current state of the art in there. I do think that we can get better at that as we learn more of how these models work and generate. But I think even that brute force approach is generating very, very good results. And given the fact that like these models are very complex to train or expensive to train, but the inference time is actually relatively light and low. So you could do a bunch of inferences and then pick the ones that you want that are best. And from like a cost and time and value point of view, that actually is probably a very reasonable approach.
It's all about the word best, right?
Yeah. Exactly.
Yeah, true. And this is exactly, well, there was a nice blog post that was a teardown of the JavaScript component of Copilot's VS Code plugin. And one of the things it suggested was that they were generating multiple candidates, and you can actually page through some of the candidates, but like in the VS Code interface, but that they were actually generating K candidates and then ranking them using a second pass quality ranker. And this is very similar to like what you see with like search relevance and like feed relevance architectures, where it's like generate many candidates cheaply and then have a sort of truly second pass ranker to help pick the best. Like this again, like is another piece of evidence that like the old techniques may help us make better decisions. I mean, I think just to go back to the Bohr loop question, this is why you have randomized holdout buckets and A/B tests, so that you don't maximally optimize your user metrics by refitting the original model you shipped. You need a random bucket, and like it's the same thing with like poisoning the well of data on the internet. I do believe that a lot of the old techniques that we've used over the past 15 years will help us build useful products in the next 10.
Okay, let's talk one last question on an industry question, and then we're going to wrap up a little bit. With the FANG companies having such a head start, where can startups find white space, and what keeps this from becoming the next version of the quote unquote Amazon tax?
I think that actually the space of applications is very vast, and most, the FANG companies are not playing in there. And so that's a wide open space for startups to go look into, is how could you provide LLMs into making, tax associates or law associates more effective, or pick your area. There really isn't that innovation happening there yet. And so there's plenty of white space there if you just look in the right places. And I think you have to move yourself away from the actual like models and training and stuff like that. That is moving very, very fast, and a lot of that's going to become commodity. But the applications, it's still very early, and probably the state of the art for most of these startups is I just call OpenAI. So there's a lot of opportunity to do better than that and figure out the right UI and UX loops and the right data flywheels, so you collect data so you can build and fine tune and make your own models better. I think there's tons of opportunity in that area.
Well, and you've hit on a couple of things, like if you're a company that believes in sustainability, maybe you're filtering your responses to reflect answers that reinforce that or are consistent with your brand. Whatever we used to buy spell check software, now it's just squiggly lines in docs. So embedding a lot of these things into other existing systems, I think is kind of an untapped world. Pretty fascinating. So obviously I could spend more, I love talking to both of you anyway, but I could spend more time just asking these dumb questions. Thank you so much for this. A little bit of a wrap up. So this is the first of a series of events we're going to do like this. Olivia's been pushing some stuff into chat here. We've been soliciting a bunch of thorny, provocative statements to build some Oxford debates around. Ravi, why don't I hand it back to you? Thank you so much for setting this all up. And why don't you give us some closing remarks and tell people how to give us feedback and stuff.
So first, it's great to have so many friends on this discussion today, not just the ones with the video turned on, but the people in the audience. So thank you all for coming and for the great questions. Sorry we didn't get to all the questions, but that's an opportunity for blogs, Alistair, or future events. And you probably saw Olivia's note that we are planning an Oxford-style set of debates, and so please send us info@hivedata.com, email if you have any ideas, or respond right here. Thank you, Mike, for helping inspire this event, and Sam for participating. And as always, Alistair for great and provocative kind of moderation. Olivia?
Yeah, thank you so much, everyone, for joining. Alistair, Mike, Sam, for being on the panel. This session will be recorded, so will be available on our YouTube hopefully later on this week. And then we're excited for the upcoming future events, so make sure to join our meetup group.
Great.
Thanks, everyone.
Well, thank you, everyone. Have a good day.